In this video, I'm going to talk about logic. So we've got logic statements, which are known as conditional statements. We're going to learn to write the inverse, converse, contrapositive of those. And I'll discuss what the biconditional is, but we won't actually write one out. And then we're going to write these statements as symbols. And we're also going to be able to use either the law of detachment or syllogism to come to some form of a conclusion. So a conditional statement is going to be an if-then statement, okay, that has a hypothesis and a conclusion. So if, I'll come to the bottom here, I've got an example. If you pass the SOL test, then you do not have to take the final exam. Okay, so that is an if-then statement with a hypothesis and a conclusion. Now, the hypothesis is going to be the part of the statement that's after the word if, but before the word then. So if we come down and we look at our statement, our hypothesis is going to be you passed the SOL test. Okay, and we actually represent the hypothesis with a letter P. So this is my P. The conclusion is going to be the part after the word then. So you do not have to take the final exam is going to be our conclusion, and we represent conclusions with the letter Q. Okay. So there are three different ways that I'm going to talk about how to change the statement, and then I'll tell you what the biconditional is. So remember, our statement is if you pass the SOL. So I'm going to first underline my P, okay? Then you do not have to take the final exam. So that's my Q. You do not have to take the final exam. That's my conclusion. So for the converse, okay, we're actually switching the hypothesis and the conclusion. Okay, we switch the hypothesis and the conclusion. So our statement would be, if you do not have to take the final exam, you passed your SOL test. For the inverse, we negate both. Okay, so we add that word not. If you do not pass the SOL test, then you have to take the final exam. Remember, in the original one, it was you pass the SOL test, then you do not have to take the final. So we negated, we switched. So if something was a not, we took the not out, and if there wasn't one, we added it. The contrapositive is going to be to switch and negate. So we're going to say, if you have to take the final exam, you did not pass your SOL test. Again, the key is that we switched the P and the Q's, and we negated. So we got some important symbols that I've already given you, and we're going to actually go back and look at symbols once we've talked about them. So we know that the hypothesis is P, the conclusion is Q. Now to negate, like we do for the inverse, it's the little squiggle is what I call it. We used it for the similar triangles as well. An if-then statement is P then, so this arrow stands for then Q. Okay, and is the caret. I say it looks like an A, so that's how I know it goes with and, so it's A without the line in between. Or is a V. If and only if, which is those biconditionals, is going to be the arrow, double-sided arrow, and therefore is going to be three dots in the form of a triangle. So I'm going to head back over to our converse statements and talk about them with the symbols. So remember, converse, we switched our P and our Q. So it was Q, then P. For our inverse, we negated. So we had not P, then not Q. And for our contrapositive, we switch, so not Q, then not P. Now this is where I want to just put in a tidbit about what the biconditional is. Okay, the biconditional is an if and only if statement, and it's only going to be true when both the inverse and the converse statement are true. So when we make an if and only if statement, we would say, you passed the SOL test if and only if you did not have to take the final exam. So that is the biconditional. Again, if and only if lets you know that it's biconditional. So now let's talk about a few laws of logic. So our first one we're going to talk about is the law of detachment. So if the hypothesis is true, of a conditional statement, then the conclusion of that statement is true. But if we know that the conclusion is true, we can't assume that the hypothesis was the reason why it happened. So for example, we have got if it snows, okay, so that's my P, it snows, we will not have school. We will not have school is going to be my Q, even though I didn't put the word then in there. It snowed on January 15th. So we know that it snowed on January 15th, which was our P. So then we can assume the Q. So we can assume now our conclusion. So therefore, we did not have school on January 15th. Okay, for our next example, we've got if it rains, that's P, you will not have practice. Not having practice is our Q. Then they tell us we did not have practice, so that's our Q. So here we can't conclude anything because they gave us the conclusion. So we could have not had practice because I hurt myself, right? There's other reasons that I could have not had practice. Maybe the coach got sick, right? Again, we cannot form conclusions from conclusions. For law of syllogism, okay, if you're given two conditional statements where the conclusion of one conditional statement matches the hypothesis of the other, you can create a new true conditional statement. So let's take a look. If you do your homework, P, you get to go shopping, Q. Okay, if you go shopping, Q, you will spend money. That's our new piece, which would be R. So notice that my hypothesis, or sorry, my conclusion matches my hypothesis. So we can take those out and combine P and Q. So our statement would say, therefore, okay, if you do your homework, you will spend money. Okay, last one here, last example. If you hit your sister, so you hit your sister's P, you will be grounded. Q. If you hit your sister, well, that's P again. She will hit back. That's a new piece. Now, since our middle pieces did not match, right, the conclusion did not match the hypothesis, we can't assume anything, so therefore we can make no conclusion. If you have further questions about logic, please make sure you ask and check out the practice in your review packet.